Good morning. Today we'll talk about thermal storage system. What is thermal storage system? As the name explains itself, a system which can store a thermal energy in itself and can give you or can be released at the time when you need it in case of power failure where the refrigeration system is not working or in case of higher tariffs. So let us first understand the components. We need a brine chiller. What is brine and what is chiller? So first let us understand what is brine. Basically, it is a mixture of MEG, methyl ethylene glycol, and normal water. Why we are mixing methyl ethylene glycol in the water? Because the freezing point of water cannot go below 0 degrees centigrade. Now to pull down the temperature, freezing temperature of water below 0 degrees centigrade, we need to add a fluid which can enable the composite fluid freezing temperature below 0 degrees centigrade. What are the properties of MEG? Let us first understand that this brine is known as the mixture of MEG and water. Okay, so we are assuming that we need a brine of temperature say 25 degrees centigrade negative, right? Okay, then there is an STL tank, thermal storage latent. This is full form basically. There is a secondary pumping system. There is a thermal three-way valves. There is a bidirectional flow meter. There is a PHE. There is a load. There is pumps. This is a very simplified system which I am explaining through the illustration shown here, right? So let us start. There are two important terms in any thermal storage system. One is charging and one is discharging. What is charging? Basically, charging. Okay, let us first understand by your usual terms. You have heard about power banks. I believe 90% of the people are having power banks in their houses. Why the power banks are used? Okay, to charge your mobile phones when the power is not there. Oh, okay, when you are traveling, when the power is not there or not easily available, you need a power bank. This power bank can be charged from a single phase supply of your house and can be disconnected once the power bank is charged fully, and then that power bank can release the electricity power to your mobile phone to get the charging of your mobile phone as well. The simple logic we can apply in this situation as well. Why and how? So idea is to charge this STL tank by thermal energy and get it released on when as and when required. So charging is the process of charging the tank. Are we charging the tank? No, not at all. We need a secondary solution or a secondary refrigerant which can be charged by brine solution. So ionized water filled nodules. Ionized water filled nodules. What are nodules? These are plastic balls which we have play, I believe, in 10th in when we were in the childhood we have played with the plastic balls, I believe, and few of you have also played with the ball. The ball is of 100 of diameter and is filled with ionized water. Why ionized water? Because ionized water can go, the freezing point of ionized water can go below 0 degrees centigrade, right? So charging will enable these nodules filled with ionized water, okay, and then we can get a term another is discharging. What discharging is? Discharging is similar to charging your phones by means of power bank. So power bank is getting discharged and your mobile phone is getting charged. In a similar manner, the discharging will happen when your STL tank is getting discharged. So what system is getting charged? Of course, a conventional refrigeration system or a conventional air conditioning system is getting charged. Let us see how. Let's focus on this diagram. Let us start one by one. This is a brine chiller. There is a secondary pump. There is a three-way valve. There is a bidirectional flow meter. There is a STL tank. Again, there is a three-way valve. And there are two lines we can see separated out. One is going again to the brine chiller, and another one is bypassing the brine chiller and connected to the PHE. So, there's a flow meter. This is a bidirectional flow meter. Why this bidirectional flow meter is shown here? Because this cycle can be reversed. How? I'll tell you. Brine chiller will charge the system. Okay? This cycle cannot be, it is an irreversible cycle. It cannot be run like this. I mean, the water cannot go from pump to chiller and then to STL tank. Brine must flow through this three-way valve to the brine chiller, to the secondary pumping system, to the bidirectional flow meter and STL tank. So this charging process must be follow one direction only. What make it different? Why the bidirectional flow meter is required? Because we need to discharge the tank. Now, to discharge the tank, what should we do? What should we need to do? These are the PHEs. Now, the tank is charged. Now, we wish to discharge it. So, there is a pump. I forgot to place a pump here. Let us make a pump here. Okay, so this is the pump. This is the pump. This is pumping the brine. Okay. Now this cycle starts. When the tank is charged, okay, and this all can be controlled by the PLC or the BMS system, the building management system. When the system is cut off, this cycle is cut off from the system. The next cycle will start as charging to discharging. This pump will get started. The flow of the brine will go like this. This is discharging from STL tank to the bidirectional flow meter. Now, this is the three-way valve. What will happen to the three-way valve? This circuit. This circuit will be open when the charging is going on. But the same system will be shut off and this cycle will get opens when the discharging is going on. Through the PHE, the brine will come to the pump again, then to the three valve again. Again, this circuit is off. This circuit is on. So brine will flow again like this. Again, this circuit is off. This circuit is on. Once the complete STL tank is getting discharged from the system, this circuit will again closed. This circuit will again on. This is closed now. This is off. On when the STL tank is completely discharged. Now the idea is to start the brine chiller, the pumps, this whole small circuit. Again the charging will be done. Then this discharging will be done. So I believe in brief you have understood what is a discharging and charging system. Now we come to the PHE system. What is PHE? These are the plate heat exchanger, guys. In the plate heat exchanger, what happened? That the heat transfer will be carried out from primary refrigerant to the secondary refrigerant. How? There are plates from which the primary refrigerant is flowing. Another circuit is connected to the load. What is the load? Load is a building where this chilled water need to be supplied. Now, not brine water, chilled water, because brine is much more costlier than a normal water. Here we need a temperature of 5 to 7 degree centigrade. But here the brine is flowing in the circuit maybe 20 to 25 to 20 degree centigrade negative. So here, if we see here, what is the temperature of the brine? there is a control. Temperature can be controlled. So we can assume that minus 10 degrees centigrade is the brine temperature and the water temperature will be 5 to 7 degrees centigrade. So this heat transfer will happen from from primary circuit to the secondary circuit by gaining the temperature of this brine. This brine will become, say for example, 0 degrees centigrade of the brine temperature, and this will become the secondary water will become, this is 5 degrees centigrade here. Sorry. This is 12 degrees centigrade for example, and the outcome will come down by 5 to 7 degrees centigrade. This will be supplied to the load, where again the heat transfer will took place, and the temperature of the water become 12 degrees centigrade. Again it enters into the PHE, where the temperature is 0 degrees centigrade. You need to understand these two terms. When the brine is exiting the PHE, the temperature is 0 degrees centigrade. And when the temperature of water is entering it's a counterflow PHE basically, where this kind of minus 10 degrees centigrade brine is coming, 12 degrees centigrade water is coming. So heat transfer took place here, and the 12 degrees centigrade water is converted into 5 degrees centigrade of water, and minus 10 degrees centigrade of the brine is converted to 0 degrees centigrade of water. It's just an example. If we can go by details in the measurements, in the calculation, in the further session. So goodbye for now. I believe you have enjoyed this session. Thank you very much.